Section 4.2 video, part 1. There may just be one part to this video. So what we're going to look at in this particular section is we're going to be looking at exponential equations. Now, so far this semester, we've looked at different types of equations. The first type we looked at was a linear equation. That's where you get the x's on one side, numbers on the other. That's where your x was to the first power. And we've looked at quadratic equations. A quadratic equation, the distinguishing feature in it was your x was squared. But regardless, whether it was a linear equation or a quadratic equation, regardless of what type, whether it was either one of those, the goal was to solve it. Now, how we solve it was different. You don't solve linear equations the same way you do quadratic equations, but the goal was to solve it. So what I want to do with you first here is I want to give you the definition of an exponential equation. Now, if you've never heard of this before, most of you probably have not, you might think, okay, I'm fixing to give you a definition, and an exponential equation will be an equation with an exponent. That's not true. An exponential equation is not an equation with an exponent because all equations have exponents in it. A quadratic equation has an exponent in it. The x has a power of 2. In a linear equation, the x's have exponents on them. They're 1. So an exponential equation is not simply an equation with an exponent in it. Well, then what is an exponential equation? Write this definition down. Here's the definition. An exponential equation is an equation where the variable is located in the exponent and its base is a number. So, an exponential equation, think about what a quadratic equation is. It has an x here and it's x squared. That's what a quadratic equation is. X squared. In an exponential equation, the x is not down here. The x is in the exponent. The variable is up here. And the base is a number. So it's a number raised to a power. And then, of course, you've got to have an equal sign. So, just to show you, don't write these down yet because we're going to work these in just a few minutes. But just to show you 4. Here's an equation. Look at where your variable is at. Your base is a number. This is an exponential equation. This, your variable is up here. Your base is a number. This is an exponential equation. This one, exponential equation. This one, exponential equation. So that's examples of what exponential equations look like. Just to show you 2 more that you don't have to write down. There's an example of 2 more exponential equations. So our goal in this section will be to solve these. Well, before I do that, I need to review back over some things about exponents with you. So, if you will, pause the video now. Let me hold up just a second. Yeah. Okay, pause the video now and copy this. Okay, I'm assuming you copied this. Now, this is just a quick crash review over exponents. Just a few things that I want to remind you of. So, let's start out. Look at this first one right here. Right here first, 5 to the 4th power. Remember, 5 to the 4th power just simply means say 5 times itself 4 times. Second thing you need to be reminded of. Remember, if you have a negative exponent. If you have a negative exponent, remember that does not make your answer negative. It flips your answer. So if you have a negative exponent, it flips the base. And then it becomes a positive exponent. So if I want to do 4 to the negative 3, that negative 3 exponent flips it. And then 4 times 4 times 4 is 64. So it doesn't make the answer negative, it flips it. Next thing you need to remember, if you've forgotten, by definition, anything raised to the 0 power is 1. So this is 0 exponent, positive exponent, and negative exponent. Now, something that you may have certainly forgotten, or you may have never known, which is why we're going over this, is what a fractional exponent does. If you remember, any base that's raised to a fractional power, you can rewrite it as a radical. Let me show you what I mean by that. And you rewrite it as a radical by using a definition. So write this definition right here now. If you want to take a base and raise it to a fractional power, you write it as a radical. Whatever this number is becomes your index to the radical, and whatever that number is becomes the power. So let's work an example. So if I want to work 16 to the 3/2 power, that's just simply the square root of 16 and then cube it. Now remember, in square roots, if you do not put the index here, it's understood 2. So I don't have to put this 2 right here. I'm doing it to emphasize it for you to see it. But that 2 there does not have to be written. So the square root of 16, what's the square root of 16? 4. And then 4 cubed is 64. All right, let's do another one. 8 to the 5/3 power would be the cube root of 8 raised to the 5th power. Now, what does cube root mean? Well, if square root means what times itself twice gives you 16, cube root of a number is what times itself 3 times. So the cube root of 8 is what times itself 3 times gives you 8. 2 times 2 times 2. So the cube root of 8 is 2. And then 2 to the 5th power is 32. Okay, let's do one more here. 25 to the -3/2. All right, this would be square root. Notice I didn't write the index because I don't have to, but you can't leave it off here. But you can here since it's 2. Square root of 25 is 5. And we just talked a while ago, what does the -3 exponent do? It flips it. Okay? Last thing I want to remind you that you need to be reminded of is this. This is what's called the product rule in exponents. If you're multiplying and the bases are the same, you keep the base and you add the exponents. So x to the 3rd times x to the 8th is x to the 11th. But there's another rule in exponents called the power rule. And it simply states this. If you take a base raised to a power, raised to another power, power to a power, you keep the base and you multiply the exponents. So see, this problem right here is completely different than that problem right there. So 8 to the 3rd to the 8th, power to a power, we multiply the exponents. All right. Now what I want to do is I want to give you a note on the steps in solving exponential equations. So take this note down. Title the note, Steps in Solving Exponential Equations. Steps in solving exponential equations. Step 1. Isolate each term on opposite sides. So, in other words, here's what I'm telling you by that first step. We're only going to solve exponential equations where you have 2 terms. We're never going to solve exponential equations that have 3 terms in it. Are there some that have 3 terms in it? Yes, but we don't solve those. So, put 1 term on one side, 1 term on the other. All right, that's step 1. Step 2. Rewrite each side as exponents having the same base. Rewrite each side having exponents having the same base if possible. So in other words, you want both sides, whatever that number is, whatever that base is, you want the two bases to be the same. That's the goal. So you want to get one term on one side, one term on the other. That's not enough. You want to get the bases to be the same. Then step 3, set the exponents equal to each other. And then step 4, solve the new equation. Okay, so we're going to look at 4 quick examples, and that's all that's in this section right here. So write these instructions down. Solve the following equations. Solve the following equations. All right, here we go. Here's the first example. Now, I'm fully aware that if you're decent with numbers, in this one, you could figure this one out in your head. Because this says 2 to what power is 8? Well, 2 times 2 is 4. 4 times 2 is 8. So if you put a 3 right there, that's the answer. So the answer is 3. But in just a minute, you're not going to be able to do it in your head. So let's follow the steps that I gave you. All right, here we go. Step 1. Get one term on one side. I'm going to call this example A. Now, step 1. Get one term on one side, one term on the other. That's done. Step 2. Rewrite each side using exponents so that the bases are the same. Okay, look at the left side. Base 2. Can you rewrite 2 using exponents any other way other than 2? 2 to the first. No. So you can't do anything with this left side. Now the right side. What we want to do on the right side is try to use the same base on the right side that we used on the left side. Well, the left side we used base 2. So I want to try to rewrite 8 using base 2. So what power would I have to put on this 2 to get the 8? 2 to the third. Now, have I changed this problem? No. I've changed the way it looks, but what's on the left side is still the same. What's on the right side is still the same. But the bases are now the same. Step 3. Set the exponents equal to each other. So now set this exponent equal to that exponent, and it is solved. And we knew that answer was going to be 3. Okay, let's look at our next example. Step 1, get one term on one side, one term on the other. That's done. Step 2, write both sides using the same base. Okay, left side is base 5. Can you write 5 using exponents other than just 5? No. So I can't do anything to the left side. Now, what I want to try to do is rewrite the right side using the same base that the left side uses. So I'm going to try to use base 5. Well, can I take 5 to a power and get 125? So take your calculator and take 5 times 5 times 5. The third time you hit the 5, you're going to get 125. So this is 5 to the third power. Step 3. Now set this exponent equal to this exponent. But you can't do that till the bases are the same. Because if the bases are the same, the exponents have to be the same. Now, this is not solved. This is now a linear equation. X is on one side, numbers on the other. So add 1 to both sides to get x equal 4. And that's step 4. Now, let's check it. If I let x be 4, what's 4 minus 1? 3. And 5 to the third power is 125. Now, these next two, you're not going to be able to do in your head. So let's look at this one. 4 to the x power is 32. Okay. Step 1, get one term on one side, one term on the other. That's done. Now, let me just show you, get a little ahead of myself. Try to do this one in your head. 4 to what power is 32? So let's see. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. So you skipped over 32. So you say, well, you can't take 4 to a power and get 32. Yes, you can, and I'm about to show you that. All right, let's follow the steps. Step 1, get one term on one side, one term on the other. Step 2, try to rewrite both sides so that they have the same base. Okay? So let's look at 4 for just a second. Let me come over here to the side. How can I rewrite 4 using exponents? I can write it as 4 to the first power, or I could write it as 2 squared, because 2 times 2 is 4. Now, let's look at 32. Remember what the goal is. The goal is to rewrite both sides using exponents so that they have the same base. So what I want to try to do is write 32 using one of these bases. All right, let's try the 4. Can you take 4 to some power and get 32? No. Can you take 2 to some power and get 32? Well, let's check it out and see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So I can write 32 as 2 to the 5th. All right, so here's what we're going to do. We're going to rewrite both sides using base 2. So, what power on this 2 has to be here to give me the 32? 5. What power on this 2 has to be in order to give me the 4? 2. So, 2 squared is 4. 2 to the 5th is 32. But you cannot throw the x away. It's still up here. So put it back. Now let me flip back. What did we say when you take something to a power to a power? What do you do to those two powers? You multiply them. Well, in this problem, you have 2 to a power to a power. So we're going to multiply those two together. So this is going to be 2 to the 2x power equal 2 to the 5th. Now set this exponent equal to that exponent. And then solve this equation. Divide by 2 to get x equals 5 over 2. Now, you don't have to check this, but let me show you that it works. Remember, this was the original problem. 4 to what power is 32? Well, we just found what that power needs to be. 4 to the 5 over 2. Now, let's check to see if that works. How do we work this? You write it as a radical. Put the 4 under here. This number goes there. That's your index. And that's your power 5. Now, what's the square root of 4? 2. And then if you take 2 to the 5th power, you get the 32. So, can you raise 4 to a power and get 32? You sure can. It's just not a whole number power. All right, let's do one more. And this one we definitely won't be able to do in our head. As a matter of fact, we're not even going to be able to check this one. Okay, here we go. Step one, get one term on one side, one term on the other. Done. Step two, write both sides using the same base. So, let me come over here to the side. 27. Can I write 27 using exponents? Well, I certainly can write it 27 to the first. But can I write 27 any other way? Well, let's check. Can we take 2 to a power and get 27? No. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So you can't take 2 to a power and get 27. What about 3 to a power? 3 times 3 is 9. 9 times 3 is 27. So I can write 27 as 3 to the third. Now, can I write it any other way? Let's try 4. 4 times 4 is 16. 16 times 4 is 64. That won't work. What about 5? 5 times 5 is 25. 6 times 6 is bigger than 27. So this is the only two ways you can write 27. Now, what we want to do is see if we can write 81 using one of these. So let's check that. Can you write 81 as 27 to some power? No. Can you write 81 as 3 to some power? And you say, wait a minute, Mr. Raymond, you can write 81 as 9 squared. That's not going to help. And the reason is, remember, you have to write both sides using the same base. Did I use a 9 up here? No. So if I didn't use a 9 up here, I don't want to use a 9 down here. I got to use the same number. So let's try 3. And if this one doesn't work, we can't solve it. So let's see. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So, yes, I can write 81 as 3 to the 4th. So, come back to the problem. 27 is 3 to the 3rd. 81 is 3 to the 4th. But you have to put the powers back. Now, what do you do when you go from a power to another power? You multiply. Now be careful, when you multiply this, you don't get 3x minus 1, you get 3x minus 3. It's distributive property. Equals, and then 4 times 5x is 20x. Now, solve this one. So I'm going to move the 3x over to the right side, just be quicker. So this would be 17x equals negative 3. Then divide by 17. To get x equals 2. Negative 3 over 17. And this one we can't check because it's so messy. We can, but I'm not going to show you how to do that because it's so messy. All right, let's do one last example here. All right. Is this an exponential equation? Yes, it is. Okay, left side, base 2. You can't rewrite 2 any other way other than base 2. Now, can you write 27 using base 2? No. You can write it using base 3, but not base 2. So this problem right here, I can't solve. Now, when I say I can't solve it, that doesn't mean it doesn't have an answer. It just means I can't use this process. Because this process, you have to be able to write both sides using the same base. We will revisit this problem a little bit later on. It's kind of like when we solve quadratic equations. Did all quadratic equations, did we solve all of them by the factoring method? No. We had to solve some of them by the quadratic formula. So we will learn another method later on how to solve exponential equations. but we're not ready to go over that method, and I'll explain why a little bit later on. Okay, so this closes out this section, and there's only one video for this section.